Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving zero array transformation 2. So the problem basically states that a zero array is an array when all its elements are equal to 0. And our goal is to make the nums input array a zero array. And we want to do that with the number of queries that we are given. So in the query, the first index represents the left pointer, the second index represents the right pointer, and the third index represents all the elements that we can subtract by in between. And we want to return the minimum possible non-negative value of k, such that after processing the first k queries in sequence, nums can become a zero array. And if after all the queries are ran and there is still not a zero array, then we just return -1. So if we look at this example, in the first query, we can subtract 1 from 2 and 2. We don't need to subtract from 0 since it's already 0. So the array will become 1, 0, 1. And then in the second operation or the second query, we can subtract 1 again from 0 to 2. So now it becomes a zero array since we have subtracted 1 from the 0 index and index 2. So now it becomes a zero array. So it only needed 2 queries, so we return 2. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use the line sweep approach. Feel free to look that up if you're not too familiar with it. But basically what we will do is we will iterate through nums, and at each index of nums, we will look at the difference value at that index plus the total. While that is less than the nums at that index, then we will perform these operations until it is no longer less than the nums at this index. So how we will perform the operations from queries is, instead of needing to add 1 at 0, 1, and 2, what we will do is we will just add 1 over here at the first index, for example, and at the index at the right of the right pointer, which will be over here for this example, we will do -1. Because what we will do is after adding 1 here, we will add 1 in total. So when we get here, this will be -1 and this will be 1. And that will imply that we did not add 1 over here. Since we will always check total plus the difference at that index if it's less than the value at the nums of that index. If that makes sense. It's kind of hard to explain in words, but I think when you guys see the coding and after I go through this example, it will make more sense to you guys. So let's go over this example real quick. So first we look at num 0. The difference here plus total is less than 2. So we will perform the first operation, which means we will add 1 over here and we will subtract 1 over here. So that also just means that we have added 1 at all these places. Because when we are here, the total here will have 1 added here, but we're not there yet because we don't edit the total until we finish the first operation at the first index of nums. So yeah, we add 1 and subtract 1 here, and we check if it is still less than 2. And so we continue. And now that we have used the first query, so we need to update result to 1. And since 1 is still less than 2, so we'll take the second query, and it says to add 1 again from 0 to 2. So we add 1 here, and then we subtract 1 again over here. And now 2 isn't less than nums anymore, so we can move on to the next index. But since we've used the second query, we need to update to 2, and we need to add this by the total for the future iterations. So now we are here. Total plus this is already greater than this, so we can skip it since we don't need any more queries. And now that we are here, since the total is 2, it is not less than 2, so we don't need to take any more queries, so we can move on. And now that we reach our end of nums, it shows that we only need to do 2 queries for this example, so we return 2. The time complexity would be O of n plus m, where n is the number of items in nums, and m is the number of queries, because that is what we may potentially iterate through. And the space complexity would be O of n, where n is the number of values in nums, because that is how long the difference array may potentially be. So now let's get to the coding part. So first we will set the total to 0, and k, or the query index, will set to 0, and difference, we will do 0 times length of nums plus 1. So now we will iterate through nums for index and range length of nums. And while the total plus the difference at that index is less than the nums of index, then we need to keep using the queries we are given. So we'll do k plus 1, and if k happens to be greater than the length of queries, then we return -1, meaning that no amount of queries can satisfy the zero array. If not, then we will do let right val and set it to queries of k minus 1. And if the right is greater than or equal to index, then we will do the operation. So the difference on the left end will be the max of the left or the current index that we are on plus val. And the reason for that is because if the left is less than the index that we are on, we don't really care about the left because that implies that the operation has already been performed on the left. So that's why we take the difference of index instead of left if the index is greater than left. And on the right end, it will be 1 to the right of the right pointer. So right plus 1 minus val. And after the while condition, we need to update the total. So total plus the difference at the index. And then we can return k in the end. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section, and I hope to see you all again soon.